Okay, here's our next video about more features of polynomial graphs. So polynomial graphs have several relative maxes and minimums, and we call them relative because there's no final maximum, because this part is going to keep going up forever. This part goes down forever. But we have relative maximums that are where we turn around, and relative minimums. So together we call these extrema or turning points. And turning points is most common because it's where we turn them around. And in calculus we learn to find them algebraically, but right now we can use the max-min function on our calculator to actually find those points. So this is in the second trace menu, is max-min. All right. Our degree. So remember, degree is our value of n up here in our ax to the n. So that's our degree. And we've already talked about the degree being odd versus even and that sort of shape. So now let's think about our degree telling us about how many roots we have and how many turning points we have. So if I think about our first polynomial, that's just a line. A line has 0 turning points. And then if I think about a quadratic has 1 turning point. A cubic has at most 2 turning points, but I could also have a cubic that has just 1 sort of turning point. So when we think about polynomials, polynomials have at most n minus 1 turning points. So that's going to be our maximum number of turning points. That's going to be how many maxes, relative maxes or mins we have. Now let's think about how many times we cross the x-axis. So if I have an odd polynomial, and that's back to my line here or my cubic, odd polynomials, because they go in opposite directions, are going to cross the x-axis at least once, because the polynomial moves in opposite directions. So it has to cross the x-axis. It will cross a maximum of the degree, so we could cross 3 times, like in this cubic, 1, 2, 3. Or we can cross less by a multiple of 2. So thinking about a 7th degree polynomial, that could cross the x-axis 7 times, 5 times, 3 times, or 1 time. And when we're really talking about crossing here. Yeah. If I think about one way to draw my cubic, I could draw a cubic to look like this. I could touch the x-axis, turn around, and so when we say cross, we really mean crossing. Here I have 2 x-intercepts, but I've crossed the x-axis once. An even polynomial is going to cross a maximum of the degree or less by a multiple of 2, and an even polynomial might not cross the x-axis at all. So think about our quadratic. We could have a quadratic up here and have imaginary roots and not cross the x-axis at all. And this is what I was talking about here. So when it's tangent to the curve, then I'm touching the x-axis once, but I'm still not actually crossing it. So that's what we look like when we're tangent. And that happens when we have a repeated root or a double root. I'm going to stop this video and come back to talk about the multiplicity of roots. Well, actually I'm not, because this is what we were just talking about here. So this is a double root, and it happens anytime I have a factor that's repeated. So this is also what you'll hear me call quite often a repeated root. So in those cases, we touch the x-axis, but it's like we bounce off of it. So we don't actually cross it, we just bounce off of it. Our odd graphs, again, are always going to cross at least once because it points in opposite directions. So now in the next video, we are going to come back and start looking at graphs.